Okay. 2 years ago,
That's when it on.
sure, sure, you want me to put it on? Wow. 2 years ago, I gave a presentation here about Jupiter's moons. And at that time, there were, let's say, 65 moons. I don't remember the exact number at that point. And I said, if I come back next year, which was a year ago, to give another presentation on Jupiter, I guarantee you there will be more than 65 moons. There will be 66, 67, 68, whatever it is. Anyhow, 2 years later, Jupiter has 79 moons, which is quite a bit more than the 65 or whatever the number was 2 years ago. But for the first time in the history of humankind, maybe the history of our solar system, Saturn is known to have more moons than Jupiter. It has now 82 moons that we know of. If I come back a year from now, I guarantee you Saturn will have 85 or more moons. Most of these new moons, and there about 20 were discovered by NASA over the last couple of months, I guess. Most of these moons are very small, 3 kilometers, whatever, 5 kilometers. When we made the presentation about a Jupiter's moon, we in fact knew that there were clusters of moons. And 4 or 5 moons belong together in a way, in that they had all been part of a much larger moon eons before. It had been smashed, that celestial body had been smashed by the gravity of the planet, Jupiter, and become pieces. And this is in fact what's happened as far as the Saturnian moons are. They're very small because they're part of a much larger celestial body, which at one point was circling the moon, the planet. And it was smashed into pieces, some of them which we probably can't see yet, but will eventually become moons that we know of. So, Saturn and Jupiter have been pretty nasty to some of the moons that have been circling it, and they've been breaking them apart. What is also interesting is that of the 20 new moons that were discovered, 17 of them circulate the planet in retrograde fashion. That is, if Saturn is rotating this way, a moon is going retrograde against the flow of the. 3 of the 20 are going in the same direction as the turning of the planet. Interesting, but not terribly scientific, not a terrific scientific discovery. Anyhow, we'll see where Saturn and Jupiter end up in terms of number of moons 10 years from now. Who knows?
Jared,
Yeah.
before we go on, the bulk of those look like they're in the same plane, but not in line with the rings of Saturn. Is that an accurate depiction?
That's an accurate prescription.
So they're obviously at an angle to
Yeah.
each other, so there's discontinuity in their forming somehow.
Well, and there's no explanation at this point. I haven't found an explanation for that. But the reality is that that's where they are. That is, in fact,
Interesting.
yeah, it's very interesting. It's very interesting. And we found some interesting aspects to the Jupiter moons also. And I'm sure that we'll find a lot of very interesting quizzical aspects of other celestial bodies, even within our solar system, as we discover more and more of them, especially once we get into the Kuiper Belt, etc. Pluto being, of course, one of them.
Before you move on, Gary,
Yeah.
it is significant that they're moving in retrograde because it means they did not form
At the same time.
at the same time
Yeah.
as Saturn, and yeah, they were captured at some point. And to Mike's point, that so many of them line up in the same plane is curious.
Good. Okay. Our planet has a molten core that creates a magnetic field which shields us from a lot of the very nasty solar rays that would come at us if we didn't have one. But interestingly, the poles flip every so often. And if one went back about 500 million years, we found that at that point in time, there were 26 flips per million years. And today meaning our current astronomical society, history, we have 1 or 2 flips per million years. So something has happened to keep the flipping from becoming as prevalent as it used to be. And there are several explanations for that, but none of them proven at this point in time. The last flip was 780,000 years ago. So we're getting perilously close to when the next flip occurs. And when they flip, then at least for a short period of time, there is less protection from the solar rays, from the X-rays, etc., than there is under normal times. In human terms, we're not about to get a flip tomorrow or the day after or next week. But interestingly, it's about to happen unless something dramatically different has come around. Yes, sir?
How long does it take for the flip to happen?
Ooh, I don't know that. Steve?
No, I did, one of the briefing a couple of years ago, they were concerned because there was a south pole was starting to appear in the South Atlantic, coast of South America, a second south pole, and they were trying to figure that one out. But I think we've all heard how fast the North Pole is moving. Right now, it has picked up speed, and it's moving fairly quickly towards the other side of towards the North Pole, which of course been in northern Canada since I've been.
I heard an interesting colleague I work with was telling me he saw a documentary on Discovery, and if anyone else has seen it, let me know. But they're saying that he believes that the theory is saying because India is pumping so much water, the weight equivalent to Lake Erie every day or every week, plus all the concrete being poured for dams in China and new construction, is doing something to the Earth's wobble. Now, to me, that seemed a little strange. I heard that today for the first time. I'm skeptical, to say the least. I just wonder if anyone else saw that or can shed some light on it. Did you?
You're right to be skeptical.
Yeah, yeah.
Put this in perspective, when you have a globe,
I know.
The shellac on the globe, like a 13-inch globe or like
That is what we live.
No, that's actually thicker than the entire atmosphere. Your fingerprints are deeper than the Marianas Trench or higher than Mount Everest at that scale. So we can pour all the concrete we want. It's not really going to change much. The earthquake back in Indonesia in 2005 it was, or something like that, that massive one,
Yeah.
tsunami, that changed the Earth's rotation by like 1/10 of a microsecond or something like that. So, and that was a lot more earth moving than all the concrete you can pour.
Well, my source
we
was,
should be skeptical.
my source is reasonably good, you know, intelligent fellow, but I'd never heard this. I'm skeptical. I just wondered if anyone else had heard.
Jim?
Yeah.
Steve, what's your source in that acceleration of the poles? I don't know, just to read stuff on that.
Yeah.
I've seen something on the web on that too.
It's an article about GPSs and how they have to update the magnetic declination more often now. They used to have to do it every 5 years on maps and things like that. They have to do it more frequently now because it's accelerating. In fact, the place that tracks where the North Pole is moving is just outside of Ottawa. It's in a marsh, out in the middle of nowhere, as you would expect. But they, look for it in that context about having to update the magnetic declination more frequently now.
I think it moves 30 to 60 miles a year now.
Yeah, it's heading towards
30 to
Russia.
60 miles a year.
Yeah.
Yeah,
It's always done that. Every map data you have, it's always so many points to the second or something like that.
And it's been in Russia for the last several years.
Oh, no, no, for you, Canada, tech towards Russia.
Yeah, I don't see how it's just gonna make it flip.
It doesn't, it breaks up into a bunch of little ones, and then there's like 50 north magnetic poles and south, and they kind of go wibbly wobbly all over.
But Jerry, one of the things is how long does it take to happen? It appears to happen pretty quickly geologically.
What's a flip?
One of the ways that they can tell is you look at a certain rock that's been molten and then you've got, you can test the magnetism. The crystals, the magnetic crystals will line up with the magnetic field, which leads north and south, because you'll see them reversed as you go down in the layers, and each one of those, of course, is a million years or whatever it is between these flips. But it seems to happen pretty quickly because there doesn't seem to be a lot of biological negativity. Plants aren't here. I mean, without the magnetic field, the plants would not survive.
Sure.
So it must be fairly quick, otherwise you'd think there's more decline in plant mass.
Yeah, it's calculated about 7,000 years. For that flip to take place. From start to finish.
7,000 years?
But when it flips, it has to flip almost instantaneously.
No, it breaks up.
Because no. How could it be 7,000 years? You're saying it just kind of gradually rotates?
It deteriorates, goes around and then reassembles.
But yeah, you can't have a period of zero magnetic field, or we'd all
Doesn't
fry.
mean that-
No, you mean
breaks
going
up.
from north to south, right, is what I'm
No,
talking
it does,
about.
it breaks up.
It
Because-
breaks up into little poles, and some of them start drifting into the Atlantic. There's one in China, there'll be one in the Atlantic Ocean, there'll be one in Russia, there'll be a bunch of norths. There won't be just one magnetic north.
I'll have to
And they
investigate.
slowly drift towards each other and pass each other and then recoalesce on the other end. That's what takes them.
Can you imagine doing a polar alignment?
Yeah.
Probably taking about as long as it takes me to do a polar alignment.
Is there any fear that reduction in the magnetic field, if it happens, could affect the Van Allen belts and our protection?
It'll make Aurora in Jamaica more likely, but you still have well, as Steve pointed out, if that much UV gets to the ground, it denatures proteins. You can see mass extinction events every time this happens. So the observations don't support that the magnetic field collapses totally.
No,
Yeah. So.
Okay, to go on.
Yes.
Wait a second. I guess it is 7,000 years. So, my apologies.
Johnny, you're getting old in your old age.
Into this and then report at the
How dare
next
you say
meeting.
that?
This is an interesting picture. If you go just down there, this is a dead satellite or rover that's been there for about a decade. I think that's Spirit. And I'm just going to put it here. Anyhow, it's an interesting photo. In taking photos of Mars by the orbiting satellite, they managed to capture one of their rovers that hasn't moved for quite a while. This is Spirit, which was landed, I think, in 2004. It was scheduled to be operational for about 90 days. It lasted about 6 years. Then got caught into some kind of little trench and couldn't get enough sunlight to power its batteries, and then eventually stopped operating around 2010. It was declared dead in last year, 2018. But now they have a picture of it. Now, speaking of Mars, we're rapidly approaching the era of tourism in space, or space tourism. You know, within a couple of years, some of us are going to be flying way up into the stratosphere. It's going to cost, $250,000 for 15 minutes or whatever. But then from there, it's the moon, and then eventually, of course, it'll be Mars. And Steve is negotiating with Mr. Musk and NASA to make sure that KW RASP are the first people to get there. So the question is, once we get there, so what is there to see? What are the more interesting places in the planet that we might want to go and see? One of them would be Olympus Mons. It's a shield volcano. And you would look at it and you say, okay, it's a nice table type of platform. Remind you to some extent of when you're in Cape Town looking at Table Mountain. But the fascinating thing is that this Olympus Mons is 3 times higher than Mount Everest. It's 25,000 meters high. And while it doesn't show it, because it is formed by lava coming up towards the center and then flowing out, etc. And the result is that the average slope is only 5 degrees. It doesn't actually seem to indicate that in this photo, but the reality is that that's what it is. Which if you're a tourist and you say, well, I want to climb up there, then 5 degrees slope, that's very doable. It'll take you a while to go up 25,000 meters, but so be it. Once you get to the top, you walk around, and of course there is this indentation, caldera, whatever, that at times in the past has spewed lava and created this. This particular site, Olympus Mons, is in the vicinity of Tarsus volcanoes. And the Tarsus volcanoes, within a range of about 4,000 kilometers, there are about a dozen volcanoes, which would be very interesting to visit. All of these volcanoes are higher than any of the volcanoes that we have on Earth. And Olympus Mons itself is 3 times higher than Everest. And the question is, well, why are mountains or volcanoes or shield volcanoes or whatever higher on Mars than they are on Earth, especially since Mars is a smaller planet than Earth? And the reason for that is there's less gravity on Mars. So things go up with greater ease. So if you are finished with Olympus Mons, you walk around, ride around if you wish, and visit a couple of the other volcanoes. It'd be a lot of fun. You could actually go into them because they aren't active anymore. And of course, we've got Valles Marineris. We've got the Grand Canyon. Valles Marineris is approximately 4 times, at 3,000 kilometers in length, 4 times the length of the Grand Canyon. So not only does Mars have the highest volcano, but it has the longest and the largest canyon. And if any of you have ever gone into the Grand Canyon, which is very interesting, or as I did a couple years ago, walked on that glass walkway, and you look straight down, that's kind of interesting. Anyhow, could have a lot of fun going in there and exploring and so on and so forth. Well, all right. Then we've got the North and South Poles. The North Pole, its ice disappears during its summer, but the South Pole doesn't. So depending on whether you want to bring your cross-country skis or your downhill skis, you could have a lot of fun exploring the South Pole all year round, or the North Pole at a particular time of year when there would be snow or ice, and other times when there wouldn't be. It gets pretty cold there, but there would be a lot of scenery that would be different than what we have here on Earth. Why not? Then we have the Gale Crater. I think all of us have heard about the Gale Crater. We've got a rover that landed in there, and it's climbing Mount something. What's the mountain?
Sharp, isn't it?
Sharp, Mount Sharp. It's climbing Mount Sharp, which is, of course, in the center of it. The Gale Crater would be very interesting to visit. Maybe a little dangerous from the point of view that they have discovered microbial evidence on several occasions in several areas of the crater. And they're not too sure yet if that's caused by geology or something that was around living a few eons ago. But the point is, we don't know, therefore we have to be very careful. Nevertheless, it would be an interesting area to traipse around.
Jerry,
Yes, sir.
one of the things on the Gale crater that blew my mind when they first sent the probe up there is that they were looking at the stones, I guess, what they thought was a stream bed. And they were saying that in order for these stones, I'm sure that Trevor could feel all the things. For the stones to be rounded the way they were by water, it would have to be like knee deep and going by in like just a second for like years. And that's a lot of water.
A lot of water. Yeah. And it all disappeared. The Medusa fossae, I think I pronounced it correctly, is probably the weirdest place on the planet. Some people have said that this is proof of some UFO having crash landed onto the planet a while ago. Well, probably not. What is suspected is that the constant wind of the planet simply carried a lot of the sand and the top part of eruptions that occurred eons before then, and simply uncovered the bases of those eruptions. At any rate, it would be fascinating to walk around and investigate and take a look at this and have selfies and whatever else. So it's a weird place.
Jerry,
Yes, sir.
why did they think that was an alien spacecraft crash?
Somebody said it. I don't think serious scientists came up with that. But
No,
some.
I didn't know if there was a particular feature on there that.
No, well, I don't know. Somebody would have crashed and then it went. Shoo.
Okay.
Who knows? If you've got an imagination, you can imagine anything.
Well, I just wondered why somebody would pick spacecraft and not an asteroid.
Whatever.
It looks
Serge?
like, looks like geodesic domes built on
Yeah,
the surface there.
it's true. Serge? Oh, I thought you had your hand up.
No, I'm just relaxing.
Okay, the recurring slope lineae in Hale crater is fascinating. A lot of people thought, in the scientific world, that this was evidence of water flowing down the slope of the crater. But more recently, people have said, yeah, it could be, but maybe it's just sand, and sand having made those grooves. Regardless, probably the tourists who would get to this area wouldn't go near the slopes themselves, because the suspicion is that in the crevices that are in constant shade could be some microbes of one type or another, and you wouldn't want to disturb them, and you wouldn't want those things to get onto you. So people would look at it from afar with spy glasses of one type or another. But it would be a beautiful sight to take a look at and admire. And finally, we've got the ghost dunes in Hellas Basin. All that is, again, are eruptions that occurred a long time ago, the top of it having been wiped out by wind, and what is left, what we see now, are simply the bases of what used to be tens of meters high, one type or another. So a lot of them have been sand dunes, but there would have been tens of meters high, and the top simply have been washed away. So hey, let's have some fun on Mars. Steve, I hope you're successful in your negotiating.
Reading today that they're expecting to send a
golf cart, I think he's mentioning a golf cart-sized rover to the South Pole of the Moon in 2021 to look for water. And I'm thinking that's going to be cool. Of course, the idea being that if they can find enough water, or ice, if you like, on the moon, with the sun is constantly going around the horizon, and all you would need is a single solar panel that faces the sun and turns like once a month. And then they could just simply, through electrolysis, you could split the water up into hydrogen and oxygen, which you would use as rocket fuel, and it would be a refueling base. You wouldn't need to pull the water or the fuel up from Earth. You could refuel from the surface of the moon, and of course, the same technology applies to Mars, which they're hoping to automate a fuel station there. But anyway, we'll look forward to that. That would be interesting. Someone? You can speak on that?
I was down in JPL last month, and I saw the new rover being built. And let's see, it's going to be like Curiosity. It's launching next year. They don't have a name for it yet, but they do have a name, the rover contest, which we can all enter.
Oh, no.
The details are on the Facebook page if you want to know anything about it. The Curiosity's job is to look for geology, and that's why they're in Gale Crater. The new probe, which is pretty much, a lot of it's made from spare parts from Curiosity, it's going to have 3 jobs. It's to look for past life on Mars, and collect a sample for sample return, and prepare for humans. So it's going from doing geology to actually more of advanced things like this. So its sensors are going to be different. It's going to land at Jezero Crater, which is near the equator. And basically it's going to be same size, same nuclear power and all that sort of stuff. So anyway, that's all of it.
Okay.
Anyone else? Let's invite Carol out.